What do you see? Do you see the past? No, you don't. You're seeing right now. This is one of the photos taken by the James Webb Telescope. It has been called the most powerful eye in the sky because it can see through time. That is a fact. However, we are going to take a step back and look at this incredible piece of engineering before looking forward into the future. Let's begin. JWST was launched on Christmas Day 2021 and arrived at its destination, Lagrange Point 2, on January 23, 2022. We are so proud of this amazing achievement. So let's dive in. The James Webb Space Telescope is more than just a telescope. It's an opportunity to understand the evolution of our universe. It is humanity's most advanced space research observatory yet. It will study the universe in ways never seen before. It will peer back in time to witness the birth of the first galaxies in the early universe. It will hunt for signs of life on exoplanets and much more. The possibilities are endless. But what makes this telescope so special? What is it about it that will revolutionize our understanding of the cosmos? Well, to answer that question, we must first talk about its three main components. Infrared vision. One of the most important things to understand about JWST is its ability to detect infrared light. Infrared light is invisible to the human eye, but it makes up a significant portion of the electromagnetic spectrum. By detecting infrared light, JWST can see things that are invisible to other telescopes, such as the heat signature of objects in space. This is incredibly useful for astronomers because it allows them to observe things that would otherwise be impossible to see. For example, infrared light can penetrate dust clouds, allowing us to see things that are hidden from view. This is especially helpful when studying things like star formation, which often occurs behind dust clouds. By being able to see through the dust, JWST can get a better understanding of how stars form and evolve. In addition to being able to see through dust, infrared light is also able to travel much farther than visible light. This means that JWST can see objects that are much more distant than what other telescopes can see. As light travels through space, it gets stretched out, causing it to shift toward the red end of the spectrum. This is known as redshift. The more distant an object is, the faster it is moving away from us, and the more redshifted its light will be. Because infrared light can travel farther, it is less affected by redshift, meaning that JWST can see objects that are much more distant and therefore much more ancient. This is incredibly important for astronomers because it allows them to study the early universe in greater detail. By being able to see back in time, JWST can help us understand how the universe evolved over billions of years. Large mirror. Another important thing to understand about the JWST is its massive mirror. The primary mirror of JWST is made up of 18 hexagonal segments that are each coated with a thin layer of gold. The segments are made of beryllium, a lightweight metal that is very strong and resistant to heat. The gold coating is important because it reflects infrared light very well. The large mirror is important for a few reasons. First, the larger the mirror, the more light it can collect. This is important for telescopes that are trying to observe very distant objects, as the light from those objects is very faint. The larger mirror of the JWST will allow it to collect more light, and therefore see fainter objects. Second, the large mirror will also allow JWST to achieve a higher resolution. Resolution refers to the amount of detail that can be seen in an image. The higher the resolution, the sharper the image. A higher resolution is also important when observing small features of an object, such as the rings of a planet or the surface of a star. Finally, the large mirror will also allow JWST to have a wider field of view. This is important for surveys of the universe, such as the Dark Energy Survey. By having a wider field of view, JWST will be able to cover more area in a single image, allowing it to survey the universe more efficiently. Let's move on to the next slide. The birth of a telescope. The James Webb Space Telescope was born out of a collaboration between NASA, the European Space Agency, and the Canadian Space Agency. After years of planning and development, the telescope was assembled and tested. Once it passed all the tests, it was time to launch. On December 25, 2021, JWST was launched aboard an Ariane 5 rocket from the European spaceport in French Guiana. After a nail-biting journey through space, JWST finally arrived at its destination, Lagrange Point 2, on January 23, 2022. But JWST's journey was far from over. Once it arrived at L2, the telescope had to be carefully unfolded and deployed. The entire process took 6 months, and it was one of the most complex space deployments ever attempted. But in the end, it was all worth it. The James Webb Space Telescope was finally ready to begin its mission. Now let's take a moment to appreciate the sheer brilliance of this technological marvel. The telescope's mirror is one of the most precise pieces of engineering ever created. Each segment is coated with a thin layer of gold, which gives it the ability to reflect infrared light. This is what allows JWST to see things that are invisible to the human eye. The telescope's sunshield is also a remarkable feat of engineering. It is 22 by 10 meters, roughly the size of a tennis court. The sunshield is made up of 5 layers of kapton, a lightweight material that is very reflective. The sunshield is important because it keeps the telescope's scientific instruments cool. If the instruments were to get too warm, they would not be able to detect the faint infrared light from distant objects. But perhaps the most important thing about the James Webb Space Telescope is its scientific instruments. The telescope is equipped with 4 instruments that will allow it to make groundbreaking discoveries about the universe. The near-infrared camera will allow JWST to see some of the earliest galaxies in the universe. The near-infrared spectrograph will allow it to study the atmospheres of exoplanets. The mid-infrared instrument will allow it to observe things that are hidden behind clouds of dust. The fine guidance sensor will allow it to image things with great clarity. Together, these instruments make JWST the most powerful telescope of its kind. It will be capable of making discoveries that were never before possible. It is already beginning to reveal the secrets of the universe. The first images released by JWST are nothing short of spectacular. They show a level of detail and clarity that has never been seen before. One of the most remarkable things about these images is the color. The universe is not actually colorful like this. These colors are the result of post-processing that has been done on the images. The reason for this is that it makes it easier for humans to interpret the data. However, it is important to note that the colors are not wrong. They are simply different from what the universe actually looks like. One of the first things that JWST is doing is looking at the early universe. By peering back in time, the telescope is able to see the first galaxies that ever formed. These galaxies are incredibly distant and therefore very faint. But JWST is able to detect them thanks to its advanced technology. JWST is also looking at things that are hidden behind clouds of dust. Clouds of dust are a common sight in space, and they can often obscure our view of the universe. However, JWST's infrared vision allows it to see through the dust, revealing the wonders that lie beneath. This is allowing astronomers to study things that were never before possible. Another thing that JWST is doing is looking at exoplanets. Exoplanets are planets that orbit stars outside of our solar system, and there are billions of them in the galaxy. JWST will be able to study the atmospheres of these planets, looking for signs of life. The discovery of life elsewhere in the universe would be one of the most important scientific breakthroughs in history, and JWST has the potential to make that discovery. As the James Webb Space Telescope continues its mission, we can expect many more amazing discoveries. The telescope is only getting started, and it has the potential to revolutionize our understanding of the universe. From the birth of the first galaxies to the search for life on exoplanets, JWST is making it possible. We hope that you enjoyed learning about the James Webb Space Telescope. This incredible machine is already making amazing discoveries, and we can't wait to see what it does next.
Thanks for watching.